Hello and welcome. I'm your host, Charles Payne. Today we're joined with Mark Davidson with AnyLog. Hello, Mark. How are you doing today?
I'm very well. Thanks, Charles. How about yourself?
I'm doing well. It's always a fun day when you're fighting with cybersecurity issues and computer glitches. It's an amazing marvel.
It is always a challenge.
I know today we're going to be talking about AnyLog. Can you give us a high-level perspective of what we're going to be talking about today in terms of AnyLog?
Sure. AnyLog is distributed data platform, specifically around, traditionally around IoT data. One of the things we've noticed is that for most customers with IoT today, they're having to ship all the data to the cloud. And at the cloud, that's where ML and AI modeling is being done. One of the things we found is that a lot of data is not being sent to the cloud just because of the volume of data and how much of the cost in cloud resources they're having to do to process that data. So one of the things that AnyLog has done is trying to turn that on its head and say, okay, data should sit closer to the devices collecting it. So we're putting data at the edge, but providing centralized ability to query that data and leverage it.
So in short, you're basically making all of the data accessible from the endpoint itself or from the edge device itself.
Yeah, exactly. So if you've got 1,000, 2,000, 3,000 endpoints, you've got essentially parallelism built into that automatically. So I'm collecting that data at each edge. I'm storing that data at the edge, and then I provide a central mechanism to access that data. But that data is being distributed and responded to by all the different nodes in the environment versus a central data store.
That makes sense. So let's walk through the process, at a high level. So if we're accessing all of the data at the edge, wouldn't that kind of slow us down if we're querying so many things all at the same time? I mean, I know that we're saving a lot of the compute, but can you walk me through about maybe some of the advantages and how you guys actually leverage everything at the edge and why it actually becomes a little bit faster by trying to actually query it from the edge device itself as opposed to just querying it from a central location?
Yeah, a good question. So if you look at it, you've got this data distributed. So when I run a query at a database, I can run parallel databases to distribute various tables and federate that data at the core or at the cloud, and to try to gain performance. But what's interesting is that your sensors are already distributed throughout the environment. So when you issue a query to an AnyLog system, what ends up happening is that all the systems that maintain a piece of that data query all respond simultaneously. So you actually get very, very quick responses, very quick results, because all you're doing is moving that data as part of the query instead of having to move every bit of data to the cloud and then querying the cloud.
Interesting. So you're actually saving me compute and bandwidth because you're not actually transmitting all the data, basically making it redundant. You're keeping it where it was actually originally collected. So you're not
Correct.
creating some type of redundancy, so I'm not wasting space there, and I'm not overutilizing and overspending for cloud compute.
Or
So
bandwidth. Yeah, if you think about it,
true.
especially if I'm using cellular connected instruments, bandwidth becomes an issue as well. So that actually reduces some of the bandwidth needs in addition to the cloud compute needs.
Interesting. And what type of device tied to what type of endpoint device or edge device could we expect to use or utilize these? So like you have like a use case that might be beneficial for maybe some of the listeners to try to conceptualize.
Sure. So in most IoT cases, there's some sort of edge device collecting data, especially with legacy devices. You've got devices such as Modbus, BACnet, OPC UA. These are all query um, interfaces. They don't push data into something. So you literally, in many IoT use cases, have to put some sort of edge compute device out there so that queries that legacy data. And then that edge device then pushes it into typically an MQTT or some sort of streamer that goes into the cloud. We eliminate that because what ends up happening, I can leverage that edge compute device to actually um, format and put the data into the AnyLog system so that when I query, instead of querying that central store, I can now query all the edge devices that are pulling the data in from the sensors at the same time. One of the other examples we're using is we actually can deploy on switches and routers. So as sensors flow in to switches and routers, that is actually pulling the data into the AnyLog system so that when I run my queries, my switch is literally responding to that and pulling the data from the sensors themselves.
Interesting. And how do you actually distribute all of the logs and all of the queries? How's that all done?
Yeah, that's a very good question. So one of the things that we do is we leverage a blockchain. So a blockchain contains all of the metadata for all of the nodes out in the environment. That metadata contains effectively the ability to the columns of data that each device as it flows into the AnyLog system uses self-described data. So as it flows in, the AnyLog system actually understands the formatting of that data and creates effectively columns at the edge. And the blockchain contains which nodes contain which columns. So when I run a query, that query leverages the blockchain at that point to say what nodes should respond to this data and then pushes the queries out to each individual node.
Interesting. So it really functions like an actual distributed ledger across the environment or across the ecosystem.
Yeah, it's interesting. It's not just a distributed ledger as well. We also use it for orchestration. So one of the things we'll talk about in a few minutes is how we could leverage this distributed environment now, not the centralized environment, but this distributed data acquisition environment to actually do distributed ML and AI modeling. So I can actually push models out to the edge and allow them to process just that instrument. And then what's interesting is because it's a peer-to-peer network, that instrument can then talk to all the other like instruments and leverage that without having to move, again, all that data to the cloud to do that.
That's interesting because I know that as we're, internally doing, AI and predominantly ML because AI doesn't really anyway, but
Right.
predominantly ML functions, it's quite expensive to actually do all of the compute using our machine learning models. Our machine learned models are supervised models. So can you talk to me a little bit more about like why you guys do that on the edge devices themselves as opposed to the, maybe the obvious answer is the fact that it's just cheaper and it's a lot more efficient.
Yeah, it is cheaper and more efficient because obviously the volume of data is different at the edge than it is in the cloud. Um, but I still have access and I can distribute it across the wider area. Not all models, though, and not all learning can be done this way. So in some cases, we still have to use centralized ML modeling, but the data still resides at the edge. So the MLs will just grab the data from the edge, run them centrally, and then we use the orchestration layer to push those models back down to the edge devices. So while we can distribute those models, we can't do that for all. Sometimes we still need the power of something like a GPU in the core or in the cloud to actually process the learning. But then we'll leverage the orchestration layer to push those models back down to each edge point.
Interesting. So it basically, if you're not able to do it on the edge device because it's way too power hungry for the device itself, you're able to actually orchestrate it in the cloud and then re-push it back down and disseminate it to across all of your infrastructure, all your IoT devices. So that, again, I guess that would still save time and bandwidth, wouldn't it? Because if you're doing it in one central place, but then you're still pushing down all that modeling and all that actual, telemetry data, it would still be able to be utilized in all of the endpoints and all the edge devices.
Yeah, if you think about it, we've talked to various manufacturers, companies such as Rockwell, and one of the problems that they have is they call it the dual loop, where you have to push the data up to the cloud, process it, and then leverage that data back down at the edge. What we're doing is eliminating that initial push, and we're just doing the model push back down to the edge at that point. So it really does save a lot of time. So a lot of our modeling can be done in near real time instead of, offline like it's done in most cases today.
Interesting. That makes sense. So I'd like to dive a little bit deeper into maybe some of the way that you guys do some of your ML or maybe your AI, distributed modeling. Can we talk a little bit more in depth about how some of those functions might work?
Yeah, so as data flows in, it gets stored at the edge. And yeah, in the traditional sense, your AI engines, your neural engines, and your GPU sitting at the at the cloud layer can query that data, process it, and then once the models have been learned, then leverages that orchestration layer built into the blockchain to push that across all the members that subscribe to those particular tables, those particular models. So that in and of itself is how the system operates. Does that make sense?
Yeah, absolutely. It seems like it does everything pretty efficiently. It seems like it, does it once. It's kind of like going back to the early EPROMs or the PROM drives, where it's like you write once and you read many. It
Or
seems like
right many.
it seems like we're back to the basics again. It seems like it does the job, it does the work once, and then it just disseminates it back out through all the members to go back and rerun it as necessary for whatever the form and function is for the task it's trying to accomplish.
Yeah, that's exactly right. It's a good analogy. Fortunately, it works a lot faster than the reads on an EEPROM, but absolutely, that's exactly it. Is once you get the data into the system, there's no need to move copies everywhere. That data exists. The other interesting avenue around it is around data governance. Because the data sits with the sensor, the ownership of that data sits with whoever owns that site or the location or the machine that that data resides on. So I now have governance. I don't have to keep copies of that data in the cloud and worry about cloud permissions and who owns this and who can access that. It sits and is completely owned. Only the views of the data can be seen, throughout the enterprise, not the actual ownership of the data itself.
Well, that's interesting because, in the cloud, you have this shared responsibility model where, if something happens to it, it's kind of so bad, too bad, so sad, it's, your fault. You should have done more to secure your network and your environment and your cloud infrastructure, et cetera. But I mean, I guess maybe another benefit to, a secure ledger is the fact that it is encrypted, it is secured. And I'm assuming that your company is also leveraging those type of aspects of the blockchain technology and the distributed ledger platforms.
Yeah, so as I said, the blockchain is used for two different purposes. One is to store um, what nodes have what columns of data. And any additional metadata that you want to add to that data. So let's say I want to add a location. I've got a sensor. It doesn't know its location, but I want to add some metadata to that sensor to that, let's say, have a location. So the blockchain actually includes metadata as well that you can add to that data. The blockchain also handles the orchestration layer, as we described, around moving ML models and other aspects to each node. Um, so we leverage We don't leverage the blockchain for the data though, because that makes it a performance bottleneck. Blockchain is good for a ledger, but not for large amounts of streaming data. So that's why we just use the metadata in the blockchain and then leverage the distributed nature of all of the nodes in the environment to get that data back from a query.
Excellent. I appreciate the clarification there. Sorry about the mistake. So, yeah, so essentially the blockchain just uses the distributed ledger, so it knows where to go find the data at which endpoint. That makes
Correct.
perfect sense. This way you're not duplicating the data redundantly across your infrastructure and across your network and your environment.
Exactly. We initially, when we started off, we actually tried to put the data in the blockchain, but we ran in, because it is a ledger, it has some performance issues, especially around large amounts of streaming data. So we sat back and said, how do we solve this, but still leverage the power and the capability of the blockchain? Because we see that as being a disruptor in the industry. And what we found out is that we can get the security of the blockchain around what nodes have what data, and then still go down and query. And there's another layer of security built into it. So the blockchain also passes keys as well. So we can actually have PKI between the querier and the individual nodes itself. The blockchain also handles the key management of all of those nodes as well when you use the enterprise version. That's one of the things I wanted to mention. One of the things that we are doing is we're in the process of open sourcing the AnyLog product. We actually should be announcing April 29th at the Linux Forum an open source version of AnyLog. And that won't have all the features such as queries, I'm sorry, such as security and redundancy, but it will have the basic core functionality of the blockchain, of the parallelism in data. It won't have some of the ML modeling capabilities in the open source version. That's relegated for the enterprise version.
But still sounds like a fantastic advantage because you're able to take advantage of the open source version. I mean, essentially for free because it's part of the open source community then. So, I mean,
Correct.
that makes perfect sense. So that at least you'll get the opportunity to test it and to demo the software, make sure that it's something that's going to be beneficial in your environment. And if you actually need those additional security protections and additional features in ML modeling, then you always have the opportunity for, advancing your subscription and then upgrading.
Correct.
Seems like
And
the perfect opportunity.
yeah, one of the other interesting things we're doing is we're also leveraging, you know, um, a blockchain as a service. So the other nice thing is that I could take the software, put it on, and literally just connect up to an existing blockchain because of the security parameters that we leverage in the blockchain and how we federate that data and provide the governance of the data. You can leverage a common blockchain between all of the customers that leverage the open source. And instead of creating your own system, you can join an existing blockchain and leverage that to get all the data communicating. So it's also an interesting way of sharing data between multiple companies as well. If I need a good example of that are machine builders. Machine builders want to have data about reliability and operations of their machines, but manufacturers want to know certain aspects of that data as well. And so that common blockchain allows us to share that data without any um, governance issues.
Interesting. Yeah, I know that whenever you typically think about like a structured environment or like maybe an SQL query or something, you've always got to worry about, the data leakage or the data being spilt over from one environment to another. But with it being, duly or, encrypted using PKI on both sides, it really makes it unique where if they don't have the key, they're not going to be able to access the data on either side. And I guess that's really what's the fundamental benefit of potentially using your platform was the fact that not only is the data, easily accessible because it's logged and it's categorized in the ledger, but the ledger itself and the data points are also encrypted with PKI across the infrastructure, across the environment.
Yeah, I will say that we don't encrypt data at rest. So as the data sits on the edge nodes, that is not encrypted, but data in transit is absolutely encrypted across the platform.
And if I understand correctly, the data at rest is actually not technically 100% complete. It's actually segmented or distributed across the environment. So if they were to look at the data on one individual device, they wouldn't actually have access to technically any of the data, holistically speaking, because they would actually have to compromise multiple devices to
Multiple
actually have the
devices.
ability to
Yeah,
put it
you're
back together and
exactly
unify it.
correct. You're exactly correct. So you only have the data if you compromise one system, you only have the data for that particular set of sensors, not all the other sensors potentially in the environment. You're absolutely correct.
So I guess it kind of functions kind of like maybe like a RAID array where there's parity on the drives and it's kind of striping it across.
Yeah, that's another very good analogy. It is very much like a RAID array because literally I'm storing pieces of the data across the entire environment and they get put together when I do a query. And what's interesting is that query, the way we've designed it is basically SQL. So I can use standard SQL to actually query that data, and then it gets parallelized across all the different nodes for the response.
Interesting. So you get all the benefits and the use cases from using an actual, SQL server, but none of the other performance hits that actually, plague it.
Yeah, exactly. One of the other things that we had to spend a little bit of time with is, you know, when I don't have that data centralized, how do I do something like a stored procedure or an alert or an alarm? So one of the other ways we leverage the blockchain is that if I need to trigger an event at the edge, the blockchain is then used to trigger that event at the edge so that action can be taken at the edge. So there is a triggering mechanism in the platform so that I can handle those exception-based processing.
Interesting. So essentially, all of again, your orchestration, your remote administrative functionality comes from the blockchain and comes from the distributed ledger at the console. And that's what's used to actually push it down and then, administer or, provide, I guess, some type of sensors or alerts throughout the entire ecosystem or infrastructure. Again, going back to the whole principle of it's a dashboard, but it's also the infrastructure behind it. So it's again, it's that two-way encrypted communication between everything. I think I find the most fascinating. And again, similar to like a RAID array, even if you've compromised a disk, for example, or an endpoint, the data is not going to be very beneficial for you if you don't have, everything holistically speaking, which I guess again is why the distributed ledger is such a benefit.
Yeah, exactly. And like a RAID array, if I lose one, I'm only losing a portion of that data, not the rest of the data in the system. And even at that, AnyLog has built in the ability to replicate nodes amongst themselves. So I can literally have two nodes or multiple nodes replicate themselves so that if one node goes down, I still don't lose the data from that node. I lose the streaming type of the data, the live data, but any of the historical data I don't lose.
Interesting. So it technically really functions more like an actual like, RAID in or RAID in plus 6 or some functionality. So that's actually pretty neat. I know we had not actually spoken about that, but that's a good function to actually know that it does have the capability to do that. So it will replicate the data that's across the environment, and then also has the ability to then recreate it and rehash it, similar to RAID array. And then
Exactly.
once it's restored, then you can obviously resume the streaming. Again, just like a hard drive, if it fails, you're not going to naturally put new data on that hard drive that's failed. You got to swap it out, and then it'll recreate it, and then you can continue on.
That's exactly it. So it's a very similar technology that we've leveraged. It's you know we spent a lot of time. We've been developing this for about 3 years now, so it's well down the path of and my co-founder. Um, Moshe Shadman was a co-founder of ScaleDB, which is a highly scalable database that was acquired by OSIsoft a few years ago. And he's taken the knowledge that he had at ScaleDB and applied it to truly distributed data, not just distributed in the cloud, but distributed at the edge. So it was a problem that he saw when he was at ScaleDB. And he said, the cloud cannot keep growing at the rate that data is growing. How can I push this problem to the edge where the edge, the amount of processing and acquisition grows with the amount of systems I add, not just, pushing it all to a single cloud instance.
So I was going to wrap up and change gears for a moment, but before I do, it dawned on me something else because we've got a lot of offices overseas, and some of the internet is great, some of the internet's not so great in some of the countries in which it operates. So because it actually operates based on the edge, I'm really just passing a text query to the edge device to actually give me the data or locate the data on that device specifically for those sensors. So in reality, I don't need a massive amount of bandwidth at each individual edge device. I just need a little bit of bandwidth to actually get the queries back that I'm actually looking for specifically.
Exactly. A good example is Google has done this already. If you think about Google searches, early in the Google days, they actually centralized all those indexes um, in their cloud. But more recently, what they've done is they've actually pushed into the browsers pieces of code that actually do that. So when I run a query, I'm actually not running in the cloud. I'm literally leveraging each browser that connects to the internet to actually get your query. So it's the same idea of distribution is I can't do everything in the cloud, but I can distribute all that to the edge. And so that's the similar thing we're taking with IoT data.
That's an amazing idea. Actually, I didn't even know that about Google, but that makes perfect sense of why their searches are always able to search for, tens of billions or hundreds of billions of records in, a fraction of a second. That makes perfect sense of why they're actually able to scale it that way, which also makes sense of why your devices and your technology also scales in the way it does.
Right.
Because again, it's pushing everything to the cloud from one central point is great if you're sitting, in close proximity to the cloud device itself or the cloud infrastructure. Again, with our offices being distributed globally, for us, it's always a problem because if we're in another country, it's possible that if we've got our data center in the US or somewhere in Europe, the European Union for GDPR purposes, and we're trying to query or look up or whatever the case may be, we've always got that latency that's built into it. And that's always it's always a pressure or a pain point because sometimes depending on the thresholds that we're doing with our technologies, it might actually time out and cause the whole cycle to repeat itself. So it's always a problem or it's always a pain point in certain instances, at least for us, for what we're doing in terms of the queries that we're trying to accomplish.
Yeah. Good point. Good point.
So I appreciate your time today, Mark. It's been a great conversation. I really enjoy the technology. I look forward to looking for some more information on it as it's coming available. I believe that there is an investment opportunity for some folks that might be interested. Do you have a couple minutes to talk about that before we go ahead and close out for the day?
Sure, we are in the middle of raising a seed round for the company. We've been pretty much self-funded to date. And we've taken a little bit of angel investment, but for the most part, self-funded, and we're getting ready to do a seed of 3 to 5 million. So we're actively looking for partners for that as we speak.
Excellent. Well, that sounds like it's pretty interesting. $3 to $5 million seems like it's a pretty small number for what you're actually accomplishing with the last 3 years of R&D that you guys have already completed. I know that you have a pitch deck, and I know that we'll make it available through your portal and through your data store as we close out for this, and it'll be in the show notes. Is there anything else that we'd like to include, or anything else that you'd like to speak about regarding AnyLog?
No, I think we've covered most everything. I want to really thank you for the time, Charles, and I really appreciate the opportunity to speak with you.
Yeah, my pleasure, Mark. It was a great conversation. So if folks wanted to reach out to you directly and maybe get a hold of you, what would be the best way for them to reach out to you or send you an email or a question or whatnot?
Sure, you can reach me at Mark, M-A-R-K, at AnyLog.co.
Excellent. Do you have a LinkedIn profile or anything like that that they can also catch you on?
Yeah, mdavidson58 would be my LinkedIn profile. You can reach me there. You can also reach AnyLog at www.anylog.co.
Excellent. And we'll make all this information available in the show notes just to make sure that if anybody wasn't able to write it down or transcribe it correctly, we'll make sure that it's all linked appropriately. Well, Mark, I really appreciate your time. Thank you very much. And let me know if there's anything else that we can do for you in the meantime.
Thank you so much, Charles. You and your audience have a great day.
Thank you.
Bye-bye.
Bye-bye.